Hey guys, I'm Jonathan from JTone Studios, also known as the Mix Helper. Welcome to my channel. In this video series, I'm not going to speak about mixing so much. I'm going to speak about plugins and more about how can we visualize what plugins are doing to an audio signal. Of course, there's nothing compared to listening and being able to really identify what the plugins are doing to the audio and to a sound source. However, it is helpful in some situations to be able to visualize these changes and to be able to explore what some plugins are doing and how they compare to others. This is the purpose of this video series. And this first video is going to be dedicated to just show you the method, show you some tools, show you how I'm going to run the next videos. In each one of them, I will pick some plugin or a group of plugins, and I will use these tools that I will demonstrate today in order to perform this analysis. So let's dive right in. So here's a session I opened in Logic, and of course you can do this in any DAW. And I'd like to show you two tools which we're going to use throughout this video series, and then show you a few plugins and how they come up with these tools. So the first and most important tool is the spectrum analyzer. I'm using Span from Vox & Go. It's a free plugin and I highly recommend it, but you can use whatever plugin you have. I'm going to start by setting a few parameters, just that it will be more convenient for me to see the results. So I'm going to set the boundaries to minus 90 dB to minus 10 dB. Then the other thing I'm going to do here is I'm going to set the slope to 0, and you'll see in a minute why this is important. And I also would like to change the integration time to 5 seconds. Make it slightly longer integration. The graphs will be a little more stable this way. And then we'll start it. The other tool which I'm using is something to generate sound. Now you'll see that my session is actually muted right now because I'm not interested in hearing right now, just to see the visualization. So I'm using a test oscillator. This is a stock plugin from Logic. I'm sure that your DAW will have one too, and if not, there are free options that you can get to do these tasks. So I'm going to use this for two things. The first is to generate a sine wave, and the other is to generate white noise. And let's look at the white noise first, turn it on, and as expected, you can see that the white noise will generate a very flat response if we set our slope to 0, and that's the reason we set the slope to 0. Just as a side note, here's the pink noise, which has a slope of minus 3 dBs per octave, and if you set the slope to 3, this will become flat. But since we are going to use white noise for our demonstrations, we'll change the slope back to 0 and we'll use the white noise. So let's see what we can do with the white noise tool. Since this is a broadband tool, what we can do is test how EQs react to it. So here's an EQ, that's a stock EQ from Logic, and I've already set some filters already. And here I'm switching it on, as you can see, and as of course expected, this curve that is showing here on the EQ is now being regenerated in our spectrum analyzer. So you can see I have a low shelf here, which is regenerated. I have a peaking filter here, and I have a high shelf that is cutting here. And you can see a nice replication of this in the actual audio. Of course, I can change parameters. So let's look at this filter, for example, and make it wider. And as I'm making it wider, you can see that it's being replicated here. And of course, if I make it narrower, same thing will happen here. Now, you can ask, why am I doing it here? I mean, I can see the curve on this EQ. That's correct. However, not all EQs are showing the curve in a graphic way like this. Here is an example of an EQ that only shows knobs. And if I turn it on, you can actually see the curve now where you couldn't see it in the plugin itself. So let's look at what we have here. We have a high-pass filter at around 90 Hertz. Here it is here. We have a filter that boosts around 12 dBs at 600 Hertz with a very wide Q, and you can see it here. And again, if I'm making this Q narrow, you can see how this changes. The last thing we have here is a shelf that boosts more than 12 dBs at around 15 kilohertz, and you can see this here. And we can also see what happens if I'm moving it. So I'm playing with the boost boost here, so from 0 to 12 dBs, and I can change the frequency and see how it changes. And of course there's a low pass filter or a high cut filter that we can apply and see how it works. So very effective tool to look at EQs and to look at individual bands, individual filters, and see what they're doing. So that's the white noise. The other thing that I wanted to show you is how to use a single sine wave. And what can we see with this? So a sine wave is basically a single frequency. It doesn't have any harmonics, any overtones, and it just shows as a spike in its single frequency. So in this case, we set it up to 1000 Hertz, and you can see it here at 1000 Hertz. If we change it to, I don't know, 1500, you can see how it's changing to 1500. And let's change it back to 1 kilohertz, and it's right there at 1 kilohertz. This is a very powerful tool to show saturation, because now if we apply saturation, it will be relatively easy to see because there's only one frequency that's being saturated and generates harmonics. So let's switch this saturation plugin on. This is the harmonics analog saturation processor from Softube, and right now it's on the tube setting with quite significant drive, so we'll be able to see what it does. So let's switch it on, and as expected we can see the harmonics coming on to the audio. In this case we can see really how the first, second, third, fourth, and so on harmonics are coming into play. Now we can also see, and that's why this tool is so powerful, is if we change modes, let's go to solid state in this case, you can see that it has a completely different pattern compared to the tube. And if we go to transformer, it also shows a different pattern. And each one of them will also have a different sound, and a different, which eventually will bring different timbre and different saturation sound to our audio. So to summarize, these two tools are used to first generate an audio source, and then to look at how this audio source looks on the spectrum, and then we can test different plugins and see how they affect the audio. So besides hearing them, we can also look at how they appear in an analyzer, which will help us to add this dimension that I mentioned in the intro. Thank you for watching. Follow my channel and stay tuned for the next videos in this series.